Have you ever wondered what would happen if we discovered life outside Earth one day? It might seem incredible, but many believe that this could be the worst news humanity has ever received. Let me explain why. It was an ordinary night at the Mullard Radio Astronomy Observatory in Cambridge, UK. Astronomer Jocelyn Bell Burnell was analyzing data when she noticed something strange. A specific region of the sky was emitting radiation at precise intervals of 1.3373 seconds. Stars are too large to spin and emit signals so regularly and so quickly, so what could it be? Jocelyn noted everything down on a piece of paper that would go down in history. Quickly, the source of the signals was nicknamed LGM-1, or Little Green Man, suggesting a possible extraterrestrial origin. But soon, the extraterrestrial hypothesis was discarded. What Jocelyn discovered was a new type of star, pulsars. But why did we initially think it could be extraterrestrial life? Astronomy has advanced a lot since then, and today we can see even the first galaxies formed after the Big Bang. However, despite all this cosmic richness, we are surrounded by a great silence. This is known as the Fermi paradox. If the universe is so vast and full of stars and planets, why haven't we found life outside Earth? Where is everybody? After decades of searching, we still have no concrete evidence of extraterrestrial life. This leads us to an intriguing hypothesis: the Great Filter. What is the Great Filter? Basically, it's a probability barrier in the evolution of life, so rare and improbable that it's why we don't see signs of other intelligent civilizations. To understand better, let's explore the concept. Philosopher Nick Bostrom suggests two criteria for identifying a great filter. The event must be extremely rare, happening only once in history, and it must take a long time to occur even under favorable conditions. For example, the emergence of life on Earth. Life appeared about 600 million years after conditions became favorable. As far as we know, life only emerged once on Earth, making the formation of life from inorganic matter, abiogenesis, a strong candidate for the Great Filter. Another possible filter is the emergence of eukaryotic cells. It took almost 2 billion years for complex cells, with DNA in a defined nucleus, to appear. This evolutionary leap seems to have occurred only once, making this event another strong candidate for the Great Filter. Now, think about it. If we find life outside Earth, like microorganisms on Mars or on a moon of Jupiter, it could mean that life is common. And if life is common, why don't we see other civilizations? The answer might be that the Great Filter is still in our future. Finding complex life, like fossils of eukaryotic cells, would be even more concerning, indicating that the filter we will face might be extremely difficult to overcome. To illustrate better, let's go back to the beginning of our planet. Earth formed about 4.5 billion years ago. About 200 million years later, conditions became favorable for life to emerge. But life only appeared about 600 million years after that. This long interval suggests that abiogenesis, or the emergence of life from non-living matter, is an extremely rare process. Imagine that all living beings on Earth, from a small bacterium to a huge elephant, are like very distant cousins. This happens because billions of years ago, there was a first living being, a sort of great-great-grandparent of all of us. This great-great-grandparent is our common ancestor. Now, scientists try to understand how life emerged from non-living elements. They recreate the conditions of early Earth in laboratories, trying to discover how life first appeared. But so far, no one has been able to repeat this process. That's why the idea of abiogenesis, the creation of life from non-living matter, is considered a great filter. A great filter is a very difficult obstacle that needs to be overcome for life to exist. Let's give an example to make understanding simpler. Let's say Earth is like a kitchen and life is a cake. Scientists try to discover the cake recipe using the ingredients available in the kitchen of early Earth. But no matter how hard they try, they still haven't managed to make a cake identical to the first cake, the first life, that appeared on Earth. This shows how difficult it is to recreate the emergence of life. Another important point is the emergence of eukaryotic cells. Life on Earth started with prokaryotic cells, which are very simple and do not have a defined nucleus. Think of prokaryotic cells as a small one-room house where everything happens in the same space. Now, eukaryotic cells are much more complex. They have a nucleus, which is like a separate room in the house where DNA is protected. It's like going from a one-room house to a house with several rooms, each with a specific function. For example, imagine that at the beginning of life on Earth, all houses were just one room where everything happened: sleeping, cooking, working, all in the same space. These are the prokaryotic cells. After almost 2 billion years, houses with multiple rooms emerged, where you have a specific place for each activity: a bedroom for sleeping, a kitchen for cooking, a living room for working. These are the eukaryotic cells. This change was very important and happened only once in the history of life on Earth. That's why this event is considered a great filter, something crucial for the evolution of complex life as we know it. But what would happen if we discovered fossils of life on other bodies in the solar system? This would indicate that life can easily arise under favorable conditions, pushing the great filter to a later point in evolution. And if we found complex life, like eukaryotes, outside Earth, that would be even more alarming. It could mean that the great filter is still ahead of us, a challenge that all other civilizations have failed to overcome. The initial phrase, "if we ever find life in the universe, that will be the worst news humanity has ever received," starts to make sense. Finding life outside Earth might seem incredible, but it could also mean that we will face an immense challenge in the future. It's important to consider our role and responsibility, because if life is so rare, we need to value and protect our planet. And if the great filter is still to come, how can we prepare to face it? Humanity has an incredible capacity for adaptation and innovation, but we need to be aware of the challenges that might lie ahead. Now, let's delve into the history of our astronomical discoveries. Think of the moment we realized that our sun is just one star among hundreds of billions in our galaxy. This perception completely changed our view of the world. However, with all this vastness, the great silence continues. Carl Sagan, one of the most renowned astronomers, used to say that the absence of evidence is not evidence of absence. This means that just because we haven't found life yet doesn't mean it doesn't exist. But what are we doing to find it? The search for extraterrestrial life has intensified in recent decades. Programs like SETI, Search for Extraterrestrial Intelligence, have been scanning the skies for radio signals from advanced civilizations. But so far, nothing. It's like we're shouting into the void, waiting for an answer that never comes. But why is it so important for us to find life outside Earth? The answer to this question goes beyond scientific curiosity. Finding life elsewhere in the universe would answer one of humanity's oldest questions: are we alone? Additionally, it could teach us a lot about the importance of the origin and evolution of life, and even about the future of our own species. But, as I mentioned before, there is a dark side to this search. If we discover that life is common, but still don't find other civilizations, it could mean that the great filter is ahead of us. It may be that civilizations advance to a certain point, but then face an insurmountable obstacle that leads to their extinction. Let's think a bit more about the concept of the great filter. There are several hypotheses about what it could be. One of them is self-destruction. It could be that all technological civilizations end up destroying themselves before they can colonize other stars. Think about our own history. We are constantly threatened by wars, climate change, pandemics, and other catastrophes that could easily end our civilization. Another possibility is that the development of advanced technologies inevitably leads to the creation of weapons or experiments that are too dangerous to be controlled. And if all civilizations end up destroying themselves in this way, It would mean that our greatest enemy is actually ourselves. Furthermore, there is the possibility that the universe itself imposes limits. Cosmic events like supernova explosions, black holes, or even the physics of particles could create barriers that are impossible to overcome for any form of life. If it simply isn't possible to travel between the stars, we might be doomed to live and die in our small corner of the cosmos. On the other hand, there is hope. Perhaps the great filter is in our past. Perhaps the emergence of life or the development of intelligence is so rare that we have already overcome the greatest obstacle. If that is the case, then the universe may be full of life, but still in primitive stages, waiting for the right moment to emerge. So, what can we do in the face of this vast array of possibilities and uncertainties? The answer is simple. Keep exploring, keep searching, and keep questioning. Curiosity is our greatest tool. It's what led us to leave the caves and reach the stars. And what do you think about all this? Are we alone in the universe? Or do we still have much to discover and understand about life beyond Earth? Leave your reflections and comments, and let's continue this fascinating conversation about our place in the cosmos.